I'm Benjie, co-founder, chief architect of Shipyard, ephemeral environment company, and basically we manage the life cycle of your pre-production environments.
And I'm Erin Doyle. I am founding engineer at Quotient, where we are helping engineering teams improve their productivity. So, the challenge, regardless of the scale and maturity of your company, we all have times when it becomes absolutely critical that we need to be able to move fast. Maybe you're rushing to product market fit. Maybe you're trying to beat a competitor to launch a feature. Maybe your sales team promised something to a customer that needs to be delivered by a deadline. Whatever it may be, if we move too slowly, the consequences could be lost opportunities, angry or churned customers, in some cases, failed businesses. And the consequences of moving too fast, increased bugs, reduced stability, reliability, tech debt. So how do we find this balance? Sometimes you've got to move slow before you can move fast. So we're going to talk about some things that you should prioritize or spend a little more time up front that's going to help you unleash your velocity later.
Yeah, so the North Star of all of this always comes down to customer happiness, and that's what we're building. We're building companies here. We're building people that are happy. So at the end of the day, the North Star is it going to make your customer happy? And that's kind of just like a little bit of a default fallback on thing that's always good to keep in mind. So I don't know if you notice this, we kind of like pugs, so I hope you like the slides. We're very proud of these. A lot of this comes down to planning and decisions. So I can't see the thing. There we go. So planning framework, you got to start simple. It's really important that you don't over-engineer right out of the gate. Just enough is just enough. You need to make sure that you, again, don't over-engineer. You do what you need to do. And obviously just enough adjust over time. And as we go through it, you're always going to be looking back at that. We'll talk about that in a little bit. This one's good for us engineers. Don't over-optimize too early. Your dog walking app does not need to deal with Google Scale. So just, get there, but don't over-optimize too early. And then learn from your actual problems. I think that's probably the most important one. As you're going along, things are going to happen. Things are going to break. There's going to be scaling issues. That's when you need to deal with them and make sure you deal with it in a good way from a planning perspective. Here's a little quick Venn diagram that I will make the slides available later, and you'll see them in the slides. I'm sorry, in the video. Take a screenshot if you want. But basically, there's these, what should we do, what can we do, and what do we want to do? And in the middle there, in that triangle, that's where you should be living.
So when it comes time to making decisions, it can be really daunting to try to think of all of the possible implications of that decision. And you can get stuck here for too long. But really, we should expect some percentage of all decisions to be wrong or something we outgrow at some point in the future. So instead of spending too much time trying to make the perfect decision, just do just enough due diligence, make a call, and move forward. But be ready to pivot. And so here are some ways that we can kind of de-risk those decisions instead of being paralyzed by them. Design as much as possible for flexibility. Be mindful of architectural patterns that can result in tight coupling. Design code with abstractions and clear seams so that you can migrate easily if you need to in the future. Be wary of vendor lock-in. When deciding on a service, consider if it has the likelihood to continue to meet your needs as your company scales, or if it's something you might outgrow.
Yeah.
Some services have a high lock-in potential, but the value they offer makes it worth it. So know what the right fit is for your company. And then lightweight documentation, such as ADRs, for instance. These are architectural decision records that capture important architectural decisions made along with the context and the consequences. And this doesn't need to take a lot of time to do. Here's an example of a template that's pretty simple, but it allows you to capture the pros and cons of the decision compared to the alternatives, the accepted trade-offs, potential risks, and any considerations for mitigation strategies if this does end up being the wrong decision for you in the future. Having a clear and shared understanding of the work you've decided to do before you get started can save an immense amount of time and effort later. Getting extra eyes on a diagram before you start coding provides opportunities for others to point out things you may not know you're missing. Or when the logic for something is too complex for you to hold in your head, having a diagram makes it much easier to see things you might be missing or ways to simplify. And there are tools that are available now to make this really fast and easy. AI is getting really good at generating diagrams using Mermaid, and more tools like Notion and Excalibur can render Mermaid, making those diagrams easy to share. And then most importantly, make sure your team has a clear understanding and are all in agreement on what your definition of done is. And continue to review that over time. Make sure you're still all in alignment. Make it easy to track your work status so you know if you've done all those steps and you don't accidentally forget anything and we don't need to do any rework later.
Yeah, I think definition of done is the number one thing that I've used on my teams to make sure things keep moving and get it done quickly. So relentless prioritization kind of ties back to what we were talking about before. That's critical. You need to make sure that you're always taking an introspective look at various stages of your continuous review and making sure, hey, should I still be doing this, right? Avoid rabbit holes and side quests. Again, from an engineering perspective, it's our favorite thing to do. Try to stop. Give yourself 5% rabbit hole time because there's no way to get rid of it altogether, but try and time box it and minimize when at all possible. Sunk cost fallacy, sometimes priorities from the top down change and it's hard to let go. Again, from an engineering perspective, it's very hard to let go. Just do it. You're working with people that you trust, or you should be, and if they say, hey, you know what, it is time to completely change the way we're doing things, you got to do it. Now, if you have some feedback there, make sure you get clarification, but, just move on when you have to move on. And then sometimes tech debt's good, right? You don't have to solve everything right away. Some nice to-dos in the code base, very valuable. Tech debt can be good if it's intentional. Try and avoid unintentional tech debt, but also don't be scared of intentional tech debt. It's okay, again, if your dog walking app can't handle 5 million concurrents. Yeah. And here is a really good state machine. Just take a quick pick. We're out of time almost. So this is a way to make a decision tree of what to do, when to do it, and basically if you are continuing down a path that doesn't really make sense. All right, so now let's prepare for speed. Probably want to go the other way on a treadmill, typically. That's just a pro tip. But you want to have a framework around guardrails. You want to do things. So at Shipyard, a big part of what we do is we try to help make testing easy. A huge part of that is having production-like data, having full stack application testing. You want to be as close to production as possible. And that adds guardrails that you might not be, you're testing things that you actually need to. Sufficient test coverage, pretty obvious one. Rule of thumb that I use at Shipyard is, and with a bunch of teams over the years, if something breaks once, that's okay. It can never break again, meaning you write a test for it after you fix it. Also, if it's critical to the customer happiness, probably try and have a test. But the 100% test coverage, I think we all know that's unrealistic and ridiculous. Type safety, I think we know what type safety is, but it's very valuable. And then same thing we're all talking about, the CI/CD pipelines that we have. It's really important that you maintain those, keep those up to date, and especially in this AI first world that we seem to be in very soon or already, those pipelines become all the more valuable. So it's a really important guardrail with your test, integration tests, end-to-end tests, all that good stuff.
So yeah, even though we have these guardrails, when moving quickly, there's still the chance we know what's going to happen, things are still going to break. But if we have proper safety nets in place, we can hopefully become aware of the issue and fix it fast. And that could start with effective error logging. We don't want to just catch and log unhandled errors. We also want to include handled errors. Just because your application caught it and handled it doesn't mean it's not something we shouldn't be aware of and probably want to fix. And that should also include our pre-prod environments. Certainly it can get noisy if we're logging a bunch of errors coming from pre-prod. But
just Shipyard.
Or just use Shipyard. But anyway, but it's a great way to be notified of errors you may not be aware of before they get to prod. Just right monitoring. Too much data gets really noisy and it becomes easy to miss the important things. So it can lead to becoming desensitized and then you're just ignoring all of the alerts and you've got the boy that cried wolf situation. So only monitor things that are critical and actionable. And maybe consider when you add any new monitoring, look at it as being in a testing phase for some period of time, where you really watch it closely, adjust any thresholds or parameters to keep it from being too noisy. And if in the end of that period, like you're not actually finding it useful, just remove it. The other hand of that is effective alerting, making sure the right notification medium is being used that gets the right people's attention. If people don't check their email, don't send your alerts and notifications to email. Prefer chat, prefer sending these where people are, and make sure they're going to the right channel where the appropriate people are paying attention and know to watch. Don't notify the wrong team. Don't send all your alerts to the platform team, but it's an application issue, and now they've got to go find the right team to notify. They become middlemen, or they might just ignore the alerts altogether. And then finally, make it easy to take action. Include steps to resolve or links to the runbooks in those alerts. So now we're ready to unleash our velocity. We're ready to start coding. To maintain that high quality while we're moving quickly, it becomes essential that we stick to best coding practices. It's the only way we're going to prevent the technical debt from accumulating beyond the intentional level. So the goal, as much as possible, is to write clean, maintainable code that's easy to understand and modify. And that can start with good Git hygiene. When you are writing your commit messages, when you're kind of creating and scoping out your branches, always be thinking about the experience of the person who's going to be reviewing or reading that code in the future. That could even be future you when you forgot why you did the thing you did. You want to make that easy to find. Follow the campsite or scout rule, Boy Scout rule, whatever you call it. It's the clean as you go, leave it cleaner than you found it. This is the best way to keep a code base up to date. And again, fight against that tech debt sort of on a recurring basis. And also note, instead of finding something you want to improve, writing a ticket, trying to prioritize it while you've got the hood up, just go ahead and do it. Make feature flagging easy. Make it easy to add and remove feature flags. Beyond the ability to A/B test and phase rollout, it really allows you to ship incremental code changes, incomplete features much more quickly and with less risk and complexity. They also provide a really useful kill switch capability. So if you've just promoted a feature to prod and you discover an issue, you can shut it off, hopefully before any customers notice, get it fixed, and get the fix out there. And then just enough code documentation. I'm not talking about novels in your READMEs, but function and module level documentation goes a long way with readability and usability. And leverage AI to do that. It's great at writing function docs.
Trying to be a little relevant to the world that we live in now, we kind of came up with a very early coding agent framework here. This is very subject to change, but I think the themes of the things that we're saying here are really going to help make you quick, hopefully. So the big first one is config files for agents, right? So maybe it's your cursor rules, maybe it's your Claude Markdown, maybe it's your sub agents. Understand what those mean. There's different tools. There's Devon, there's Klein, Codex, there's all these different things. They all have their own different rules, but you should understand what those are, and you should have things in there giving, it's not deterministic, but you can say, hey, always use Python for this or Ruby for that, or maybe not Ruby, but anyway, Rust. Always use Rust, right? Well, cool. But you want to have things like that. You want to say, hey, always write tests, stuff like that. So I think config files and understanding them, that's really the note here. Develop in isolation. Get work trees, sandboxes, whatever it might be. It's really important that you're careful where your coding agents live. Oftentimes you might have production credentials sitting on in your shell, and oops, it deleted something that it shouldn't have. So make sure you know where you're running these agents and they're in safe places. This one I think is really important, and this is very relevant for Shipyard. It's okay to develop in a non-deterministic way. Your agent does things different ways. But when you test, it needs to be deterministic and it needs to be repeatable. And lastly, you really need to have attestations. This is a little bit more of an enterprisey thing, but for those of us in enterprise orgs, you need to have documentation. I ran these 17 tests, they all passed. We all know that in the software development lifecycle where we're just engineers and we're not coding agents, we get a little loosey-goosey with end-to-end tests. Oh yeah, I'll fix that later. Or I use a feature flag to kind of put something out there I maybe shouldn't. As we get further into this multi-agent verse, you really need to have attestations around your validation, an SBOM, if you will, of these things. So
Yeah, so now how do we measure? How do we gauge how we're performing? How do we know if we're going too fast or too slow? I'm sure most people here have heard of some developer productivity measurement frameworks, but these can really help you set a baseline and then continue to evaluate your productivity and deliver performance over time. So top frameworks include, DORA, SPACE, others, but regardless of the frameworks, which are just starting points, regardless of which frameworks you want to use, ultimately you should aim to achieve two goals. To properly measure productivity, you need to include tension metrics for a holistic view. Tension metrics are metrics that counterbalance each other to prevent over-optimization of one at the expense of others. So, for instance, if you're measuring change lead time by itself, it will tell you if you're moving quickly, but unless you're also looking at change failure rate, you may be sacrificing quality for the sake of speed. And then beyond just measuring how you're performing, you should consider the complete context of your engineering team. Combining system telemetry with developer experience data can identify bottlenecks that are getting in the way of your engineers being able to perform at their best. By improving these areas that impede developer productivity and creating an environment that's optimized for engineers to do their best work, you can really unleash the velocity of your engineering team. And so I think because we're kind of short on time, we're just going to jump to the full list.
We could have done it one by one.
We could have.
Just take a picture of this. You don't have to listen to the whole talk. Just take a picture. This is pretty good. Being sarcastic here. But Erin, I think that Erin and I got to work on this presentation together, and I feel like solidifying a bunch of stuff. It's right here. Overarchingly, don't over-engineer, but don't be too lazy. And I think the biggest thing for me, Erin, is really that customer happiness is the North Star. We sometimes forget when we're building software that it's not for perfect code. It's not for 100% test coverage. It is about the end user, and that being the ultimate kind of way to make a decision when you have a fork in the road is really the super valuable thing for me. Anything else that you want to highlight?
No, I think that wraps it up.
All right, awesome.
Yeah. So with that,
thank you.
Thank you.